Go.
Hi everyone, my name is Nath and I am here to demonstrate turning repeating decimals into fractions. So before we get started, I would like to describe what rational numbers are. Rational numbers are decimals that can turn into fractions. Our first problem, I'm going to use my handy dandy whiteboard for a decimal that does not repeat right away. So we have 0.426610, otherwise known as 42,610. I'm going to put a bar on top of the 10. That bar represents the repeating decimal, so 42,610 goes on forever and ever and ever and ever. Now I'm going to write let n equal. Now before that, I'm going to multiply by the powers of 10 until I get to the repeating number on the left side of the decimal. So let's get started. So we have our decimals, so we go 1 place, 2 place, 3 place, 4 place, 5 places. So we write 4, 2, 6, 1, 0, 1, 0, 1, 0, and etc. And we find out, since the 0's in the 1's place, the 4's in the 10's place, the 2's in the 100's place, the 6 is in the 1000's place, the 1's in the 10,000 place, the 0's in the 100,000, so our n is 100,000 minus 1,000. And then we end up with 99,000 as this side of the problem. Then we take 42,610, decimal point there, 10, as we know 10 goes on and on. We subtract 4, 2, 6, 1, 0. And we notice that our decimals are lined up perfectly. So we cross off our decimals, don't need them anymore. We end up with 421,184 over 99,000. Now, since our numerator integer is bigger than our denominator integer, we divide. We have to find something that goes into both of them evenly. The only number is 2, which I'll write down here because we're running out of room. And you end up with 210,592 as your numerator, and your denominator is 495,000. That is how you do a decimal that does not repeat immediately. Now, as I quickly erase, we are going to demonstrate one more problem, which is a bit more simpler, a repeating decimal that goes on forever. So we have our 0.54, again with our bar. Very important we have that bar, or without the bar, we are not repeating a decimal that goes on forever and ever. Then we put let n equals, and then again, we take our powers of 10 and we multiply the repeating number until we get to the left side of the decimal. In this case, it's a little bit more easier since it's a smaller number, 0.54, 0.54, 0.54, etc. 1, 2, 1 tenths, hundredths. So our n is 100n minus 1n equals 99n. Then we take our 54, bring it down without the 0, and we line up our decimals. Very important, our decimals are lined up. And it goes on forever and ever, so dot dots. Then we bring down our 54. We notice yet again, our decimals are lined up. So we cross it out and we bring down our 54. We don't need the decimal anymore. And we bring down our 99. So 54 is our integer numerator, 99 is our integer denominator, but we can do more than that. We can simplify it to make it smaller. The only one that goes into it evenly is 9. So we get 54 divided by 9 is 6. 99 divided by 9 is 11. And we end with 6 elevenths. So the reason why we do this lesson is it's very important to understand the difference between repeating decimals that go on forever, and they do, it's a whole different system, as you can see, and understand the difference between decimals that don't repeat immediately. To understand the placement. Placement is super important. I hope you guys don't forget that. Well, thank you for coming to my video. I hope you learned something, and that's all I have to say. Bye.